In the very first lesson, we obtained the time of flight of a ball which is thrown vertically upwards with a velocity of v0. Now let's watch this in animation. This is rectilinear motion in a single dimension, and our reference line is the x-axis, which means that we will be measuring all the displacements along the y-axis from the x-axis. That is, we use the x-axis as a reference. So we will be measuring all the displacements along the y-axis from the x-axis. So when the ball begins from rest, the initial displacement is 0, and when the ball reaches the ground again, the final displacement is also 0. When we plug this into the equation of motion, we have both y and y0 as 0. And from here we obtain the time of flight as 2 times v0 over g. Now let's think on similar lines for projectile motion. So for this projectile motion, we also want to find the time of flight. And fundamentally, we are using the same concept. That is, we can apply the equations of motion independently along each axis. And we will do this analysis along the y-axis to take advantage of the fact that the initial and final displacements are both 0 along the y-axis. The initial velocity is v0y or v0 times sine of theta, and the acceleration is minus g in the direction opposite to that of the velocity. Plugging this into the second equation of motion along the y-axis, the initial and final displacements are both 0. The initial velocity v0y is v0 times sine of theta, and the acceleration is minus g. From here we obtain the total time of flight as 2 times v0 sine theta over g. This is the total time, that is the time taken right from the launch to the topmost position and back to the ground. Now for a certain velocity, if we have to maximize the time of flight, then we would launch it vertically upwards so that theta is 90 degrees and sine theta would be at its maximum, so this would be 1. And we have seen earlier that the time of flight of a ball thrown vertically upwards would be 2 times v0 over g. Now when we launch a ball vertically upwards with a velocity of v0, the time of flight is 2 times v0 over g. And now with the projectile, we have a very similar looking formula, but with an additional sine theta. So essentially, we are substituting the v0 with v0 times sine of theta for projectile motion. And v0 times sine of theta is the initial velocity of the projectile along the y-axis. So the time of flight could also be expressed as 2 times v0y over g, where v0y is v0 times sine of theta. And then this formula looks very similar to the formula where a ball is thrown vertically upwards with a velocity of v0. But remember, for a projectile, it is not 2 times v0 over g, but 2 times v0 sine of theta over g. Now the time taken to get from the launch point to the highest position will be half of this. So the time taken for the projectile to move from the launch point to the highest position would be v0y over g or v0 sine theta over g. So the time of flight depends on both the speed at which you launch the projectile and the angle at which the projectile is launched. Now let's try out a simple problem so that you have some comfort with these formulas. We throw a stone with a speed of 70 meters per second and at an angle theta which is 45 degrees. What is the time taken by the ball to reach back to the ground? Or in other words, what is the time of flight of the projectile? So we are given v0, the initial speed, is 70 and we are given the launch angle theta as 45. Substituting this into the formula for the total time 2 times v0 sine theta over g and using g as 10, we obtain the time taken for the full flight as 9.9 seconds. This is the time taken to cover the entire path. The time taken from the launch point to the highest point would be half of this, so that would be 4.95 seconds. The greater the speed with which we throw the ball, the greater will be the time of flight. The greater the acute angle with which we throw the ball with the horizontal, the greater the time of flight. So if we throw the ball vertically upwards, it would give us the greatest time of flight for the same speed.